we are going to see how to analyze a simple beam. So I'm selecting space and the unit is meter and the force unit is kilonewton, and I'm going to design a continuous beam. And next we can add beam. So finish. You can see the graph here. If we need, we can edit the graph by here. This is a plane xy, xz and yz. This is the xy plane. I'm going to add a beam. Then I'm clicking OK. This is the views. You can see the front view. I'm going to do a continuous beam, so I'm selecting like for every 3 meter one beam. Okay, so right now you can select the graph. You can see this is the beam. Here I'm going to give the sections for the beam. Go to the general, define. So see here the lot of section is there. It's a rectangle. Width is 0.4, depth is 0.7, and the material is concrete. Add, then close. So I'm going to give this section, use cursor to assign like this, and this. So I'm going to add the support for this. Create the new support. You can see the different supports is there. Fixed, pinned, fixed, but release in one end and another end, like that. I'm going to add a fixed support and also pin support. Use cursor. Here is fixed, and you can see the nodes here. Okay. So 3. Okay. So right now I'm going to add the loads. Load case details. Add primary. You can select the load type. Dead load. I mention here as dead. And live load. Live. Close. So the dead load, the self weight, that means the gravity load, the factor is automatically 1. So I can add this. I'm going to assign to view, means this condition is applied to the whole structure. So this one. Then live load, you can add the member loads. Uniform force means the UDL load 5 kilonewtons. This is the distances where you need to start. The D1 means from the starting point to until where you want to start, and the D2 means the finishing end. D3 is the axis. In XY plane means in the X plane how much distance you want to load the load. So I'm giving simply in the global Y axis -5 and close. This one, use cursor to assign. I'm going to add these two names. As same live load, I'm going to add Another one member load is a linear varying. So linear varying, you can see the points W1 and W2. W1 I'm going to give minus 3. And the W2 I'm going to give minus 5. If you are giving in the y-axis means the load is acting in the y direction. This is the one I'm going to add use cursor. Okay. Yes. Now almost our conditions are ready. You can say now here the load value is not visible, so you can choose these things. Load. See, in the labels you can see the load values. Apply. Okay. So this is our condition. You can see the 3-dimensional section also by here, clicking here. So this is our condition. I'm going to run this one. Material. At the same time already we specified this concrete. You can see the material. Here is the material properties. Steel. So you can edit means you can edit the yield stress, tensile strength values. So I'm going to analyze the structure, perform analyze, the load data, static check, static load, mode shape, both and all. You can click all. Okay. Then analyze. So you can see the errors 0, warning 0 and notes 0. You can see the output file here, the complete data, member incidents, joint coordinates, material properties, then analysis details. Here is the post processing. The load conditions. Okay. This is the beam. This is the bending moment diagrams. So in the design results, here is the design results. Show diagram, show the mesh. There's Fy and Mz, Fx. These are the reactions.